So, uh, yeah, I think I would request Neha if you want to play the IHFC video. I mean, where
Yes, sir.
or
I
want
think we
to
can start with that.
while we're waiting
So,
for the other people to join, I think the IHFC video.
right,
Thank
right.
you.
So, Prerna ma'am, we'll play our IHFC corporate AV just to give you a glimpse of what IHFC is and what it does. And after that, we'll have a video about Cobotalks, what this whole session is about, and we have been doing this since long. And after that, Akash sir will briefly introduce you, and then you may take over the session, and the floor is yours. So, Akanksha, can you start the video?
Yes, yes.
See, everything is gonna change. Whatever you look around yourself, I think everything will change. All these technologies, they are going to be very, very significant in our life.
We envision that we are going to use robotics and humans and the human robotic interface for improvement of society.
That our focus should be human-robot interactions. Human-robot interaction means that human intelligence with robot's precision. We are called Cobotics. Cobotics means collaborative robotics, where human being and robot work together.
We work on technologies of the future. We look at ways in which these technologies will actually get deployed. We provide leadership in this. We work with industry.
So we have chosen four major thrust areas, we may call it. One is called the medical robotics. The second is the defense robotics. Third is the agriculture robotics. And fourth is the industry 4.0 or industry 5.0.
We are trying to build a ecosystem here. When we talk about ecosystem, it starts from the kind of research capabilities that we are able to build. How is that we are able to instill the sense of commercialization in all those activities. We should talk about how is that research getting translated into products. So I think we want to be that ecosystem, we want to be that enabler which is making that possible.
We've also got a large number of research projects and technology development. We are also creating some common infrastructure, for instance in the area of medical simulation, in the area of drones, which can be used by a whole group, so that we are trying to create an innovation ecosystem in the field of cobotics.
Some of the research, for example, prosthetic hands done by Tezpur University, the professor tells us that it is undergoing field trials with the doctors. So that's a kind of a positive that it is reaching towards the markets. Coming to the startup funding, we are very happy that one of the startup companies from IIT Delhi, Botlab Dynamics, whom we funded last year, they could show 1,000 drone swarming on 29th of January last year, which made the country fourth in the world. So that's a pride on us because we have been contributing to that part.
What an industry can offer, an academia can't. What an academia can offer, industry can't. If we all come together, that's the real value proposition for a startup. So I think that is what we are trying to build through a collaboration.
The mission of IHFC and the mission of IIT Delhi, there's a lot of synergy. And so we are treating IHFC as an extension of the things that we anyway want to do. So we've been supportive in terms of our students, our researchers, our admin and our infrastructure. We also have our faculty members writing proposals, and so some of the projects done by IHFC are actually implemented in our institute.
So we would like to see it as a global company. And when I say a global company, it's a research aggregator, actually, the way we have structured ourselves.
When we talk about DTP or MCC or READY program, these are some of the initiatives, when we are talking about students who have an intention to work in the domain of research and development, they need to be supported. They have still not made up their mind as to if they are going to start a job, they are going to start a startup, they are going to work a little bit more in terms of whatever they are passionate about. We want to give them a platform, and that is what Ready is all about.
Then we are creating 2 specialized centers which we call Medical Cobotics Center. It will be done in collaboration with IIIT Delhi. The second one is the Drone Technology Park.
And the reason we have selected Sonipat is that it is away from this red zone. So it's an easy place to test. It's an easy place to bring everyone together. So we want to create an ecosystem for testing, manufacturing, research and development, startups, incubation, training, all these put together in that space.
The first goal of success would be creating an impact in society through some value add in terms of technologies and ideas.
I would definitely want IHFC to make an impact, an impact wherein we see our ecosystem coming together to see that we as an entity, we as a country, we as an ecosystem are able to build products on our own. And that is what we want to do as a part of IHFC.
Welcome to Cobotalks, where we shape the future of human-robot collaboration. Cobotalks is a monthly seminar series held on the second Wednesday of each month, bringing together leading researchers, innovators, and professionals to exchange insights and advancements in the field of collaborative robotics. Since its inception, Cobotalks has featured 50+ experts, showcasing how intelligent robots enhance human capabilities, productivity, and key sectors like healthcare, agriculture, defense, and industry. This initiative is brought to you by IHFC, the Technology Innovation Hub of IIT Delhi, the Center of Excellence, in collaboration with BIRD, and the Cognitive Science Program at IIT Delhi's Department of Humanities and Social Sciences. The iHub Foundation for Cobotics, IHFC, the Technology Innovation Hub of IIT Delhi, established under the National Mission on Interdisciplinary Cyber-Physical Systems, NMICPS, by the Department of Science and Technology, DST, Government of India. It was launched in June 2020. IHFC operates across 4 key verticals: research and development, education and training, startups and entrepreneurship, and international collaboration, fostering technology commercialization and building global partnerships with academia, industry, and government. In application, IHFC works in advancing collaborative robotics in medical and healthcare, agriculture, industry, and defense, leading initiatives like drone swarming and medical cobotics to enhance human-robot collaboration for real-world impact. IHFC has partnered with 10 institutes nationwide to establish co-innovation centers, empowering students and entrepreneurs in robotics, AI, ML, and IoT to develop innovative solutions and high-impact startups. Aligned with the vision of our Honorable Prime Minister, Shri Narendra Modi, for a Viksit Bharat and Atmanirbhar Bharat, these centers foster deep tech R&D, skill development, and creative problem-solving, equipping India's youth to drive technological advancements and compete globally. IHFC's mission is to create a world-class ecosystem for innovation, bridging research and practical applications to enhance human-robot collaboration for societal benefit. BIRD, IIT Delhi's Center of Excellence in Biologically Inspired Robots and Drones, is a leading hub for interdisciplinary robotics research. Founded through the Program for Autonomous Robotics, in 2010, it develops intelligent, sustainable robotic systems and has been instrumental in establishing the Robotics Society of India and the Interdisciplinary Specialization in Robotics, IDSR. BIRD consists of 27 members and has produced more than 150 publications over its 10 years of operation, working on 10+ industrial and academic projects. The Cognitive Science Program at IIT Delhi offers an interdisciplinary approach to studying the human mind, integrating diverse theories and methods. It prepares students for careers in academia, industry, research, brain sciences, and human-machine interaction, leading the way in human-robot collaboration space. Join us for an exciting interaction session, second Wednesday of every month. Cobotalk.
Thank you, Akanksha. Dr. Akash, may I now request you to please introduce Ms. Prerna for
Sure.
our speaker for today's session?
So, Ms. Prerna, IHFC is pleased to welcome you, and we acknowledge your contribution as a researcher and a practitioner at the intersection of cognitive science, child development, and educational technology. Your passion about building systems about for students and children and empower them to learn and think. Uh, your MSc in cognitive science and BSc in human development and child studies is the right, I think, training for this important area. And we acknowledge that you bring the various experiences you have and the trainings you have at AIMS New Delhi and your past roles in different assignments related to AI-driven cognitive assessments and translating scientific insights into adaptive, engaging, and developmentally informed learners. We welcome you here as part of this Cobotalks. We are very eager. Cognitive science and cobotics although they are at an interface, but they also overlap at several places. So I think we would like to hear from you and your experience, the different, scenarios you experienced. And so over to you. And I'm happy to join from Sonipat along with the ready cohort 8, with 7+ students here, and some have joined online. So thank you, and over to you. We look forward to a very enriching experience sharing from your side.
Thank you so much, IFC IIT Delhi, for having me. And I am very really glad that at an early career, I get to speak at such a big event and interact with such great people who look forward to technological innovations in the future, along with integration of AI and not be scared of AI. So let me just start my presentation. Okay, can you guys see my screen?
Yeah.
Okay, all right. Okay, so the topic is emerging edtech in childhood cognition. So basically, in this presentation, I would be talking about how cognitive science in education and neuroscience principle in education can actually enhance the level, the quality of education that we are having right now, which will enhance lifelong learning and which will enhance the kids to actually be interested in academics, and if not academics, then extracurriculars combined, but then completely leading to a very staged development and perfect assessments in cognitive science. Okay, so why do we need neuroscience in education? Neuroscience supports lifelong learning. So what happens is, in humans, the developmental periods are very prolonged. Our childhood and our adolescence combined is equal to 18 years. So that gives us a very good scope of actually having this having the the facilities to better our learning and our brain development. So what happens is, during these critical years of development, we need to enhance more experience dependent neuroplasticity. And this shapes brain networks through learning. So what happens is, whenever we are learning through experiences, our brain expands its networks to enhance our skills even more. So the extensive developmental periods are actually there in order for us to actually take an advantage of the fact that we can help our brain develop at every stage of life. 18 years is just the child and the adolescent stage, but till the age of 25, our prefrontal cortex is still developing. So even if you are not able to catch up with more skills in the childhood, you definitely have some time in the adulthood. So what happens is, this prolonged period of development gives us a scope that education should leverage its period of high neuroplasticity with brain friendly means. using principles of cognitive science and neuroscience principles to maximize the learning potential of each child. And neuroscience can be used as an educational tool. Recently, it has been said that neuroscience classrooms are the best neuroscience labs. So let's explore as to how we can actually shape it up. What is neuroeducation? The how and why of learning. So, neuroeducation is an integration of three fields: neuroscience, child development, cognitive science, education, and now it's AI as well. So, what is it? We combine the principles of research from neuroscience, psychology, cognitive science, and education to first understand how the brain works, and then use the insights from neuroscience to inform and improve the educational practices, which will then help us develop curriculum design, teaching methods, and educational policies. And why do we need it? Understanding how people actually want to think and learn can help the educators develop learning experiences that are more engaging and effective. In today's day and age, with the help of technology and AI, the teachers not only have the job of teaching effectively, but they also are at a job of an architect, an educational architect who is helping the child develop and discover their own cognitive strategies to learn. And then what they do is use AI or other technology to aid the learning in order to engage the child in lifelong learning processes. What is the need of neuro-ed-tech? So that we move beyond the neuromyths. The neuromyths are such as learning strategies. They've classified the learners into visual, into auditory, into reading, into kinesthetic learners. But what we are getting about it? Suppose I don't like maths, but maybe I would understand maths very in a visual method. But on the other hand, I would like to read English in on pen and paper method. I would like to read novels. I would like to read newspapers and stuff in order to enhance my language. So here, what kind of a learner am I? It doesn't define. So by eradicating these neuromyths, neuro-edtech helps us collaborate with different domains of technology as well as cognitive science to help enhance the school education as well. Also, in today's day and age, we need to have a learning that is personalized and adaptive. We cannot have a learning strategy which fits all. This strategy of one solution fits all cannot help us solve the problems in the industry. So what solution we come up with is the hyper personalization. So if I am a visual learner in some subjects, I am a reading I'm more towards the reading side in some other thing. I maybe do some other activity to learn science. So this is how a hyper personalized model can be developed. Then we address a diverse range of needs. In today's day and age, what happens is there is a huge increase in the percentage of neurodivergence. That is because of a lot of reasons. That is because our brain is evolving in different ways. That is because maybe there's a lot of information overload and some other brain disorders, because of which we have a diverse classroom. We do not have a classroom which is homogeneous. So what happens is, if we take only one pedagogical method to teach one topic, it doesn't help. So what will AI or the help of or the concept of neuro-edtech do is they'll actually um, personalize the learning in terms of what kind of a learner or what kind of a neurodivergent learner the kid child is, and then it optimizes on the whole teaching and learning process. So a very good concept of Vygotsky's zone of proximal development comes into play. What it does is, according to ZPD model, the learning and development depends on the optimal balance between support and challenge. So what happens is there are three zones: stress zone, comfort zone, and stretch zones. These three zones are defined such as: what is a stress zone? When the learning and the performance demands exceed the available support and resources, the students are likely to be overwhelmed. If I'm having 5 different kinds of technologies in the class which are not perfectly placed according to the needs and demands of the subject or the concept that I'm teaching, then the children will be overwhelmed. And that's how the performance degrades. Comfort zone is when the learning and the performance demands are significantly lower than the available support and resources. So the students are likely to be very under motivated and resort to static mode. They won't try to be dynamic. They won't try to grow. Then we come to the stretch zone, which is kind of the perfect zone for the development. When learning and performance demands match the available support and resources, what students do is that they're likely to be appropriately challenged according to the developmental ages and work within the zone of proximal development, which will promote a healthy neuroplasticity, and it will help them express their things better, and they'll have a good experience while learning and not be terrified of any learning system. We have to bridge the gap in education with AI and neuroscience. Interdisciplinarity is the best thing that can happen. So neuroscience is one of the domains which provides the user manual for brain, while AI and EdTech provide the tools to apply it. So what happens is there are certain concepts that are used in order for these three domains to integrate. The cognitive load theory says that the working memory is limited. Obviously, we are humans. We are not some kind of a big machine which is programmed to take a lot of data at one point. So our working memory is limited, and overloading leads to cognitive overload and burnout as a result. So the solution is some AI driven tools are actually simplifying the complex information into chunks. Using very basic concepts in memory, we can actually help the child learn in a better way. Then we come to adaptive scaffolding. So what happens is if your teacher has to teach a very big concept in suppose science, maybe acid bases and salts at one go, you won't be able to capture it in in one go because it's a lot of information overload. So what the teacher would do is they would break the concept into numerous parts and then help you understand. This is a this breaks the rigid traditional education system which is not tailored to the individual. Suppose I would learn through an experiment, so the teacher would or maybe she would use the AI tools to first make me see the experiments and then learn. But on the other hand, a traditional classroom wouldn't help make me do all those experiments at first. So the solution is AI provides just in time solutions adjusting to difficulty of a task based on a student's real time performance. It fate supports as the students gain mastery. So AI here is not spoiling the kid, but they are actually helping the kid grow in that path of life. Now we come to affective computing. Affective computing is kind of a system that can be placed in classrooms where the student's emotional state, such as boredom, frustration, irritation, or maybe happiness, can be judged. So what happens is such expressions are usually missed by the teachers because they barely have time to do so. So what AI does is they use camera and voice analysis to recognize emotions and offer encouragement and change the content to re-engage the student. The core idea is we are moving from teaching a subject to teaching a child. In today's day, what happens in the basic schooling system is the teacher is there. She just comes to the class, or they just come to the class and they just finish a topic and go. But what about how the mental state of the child is? Maybe there's a lot of heat, they are not able to study properly. Maybe they have certain problems with their peer groups, so they're not able to concentrate properly. So affective computing method would help a child analyze their own emotions. It will make them own very emotionally resilient to the fact that they have to deal with the emotions while they have to study as well. So this creates a learning environment that is dynamic, personalized, and emotionally intelligent, and all by leveraging the insights of science of learning. The current application of Neuro-EdTech is used in the anatomy of intelligent tutoring systems. The examples of ITS will be given in the next slide. So what happens in an intelligent tutoring system is there is a student model, which is the brain of the system. It tracks the baseline of the student, how much they have the knowledge, how much they can actually, grasp at one go, how much misconceptions that they are there, or maybe how much cognitive load or how much concentration can they be putting into the system. Then they have a domain model, which is the knowledge base of the system. It contains all the concepts, facts, and the rules of the subject being taught. This is basically a book in the tutoring system. Then there is a tutor model, which is the teacher. They decide what to teach and when to intervene, and then how to provide hints or feedback. Then we come to the user interface. which is the classroom of the system, the way in which the student interacts with the system, like in different methods, text, voice, interactive graphics, gamings, etc. The real world examples and benefits of these ITS platforms are the Carnegie's Learning Cognitive Tutor. This is a system in US high schools to teach mathematics and to actually eliminate the fear of mathematics. It adapts to the problem and provides hints based on a student's problem solving steps. Suppose I'm very good with doing, one variable equations. So it will provide me with those questions. The moment I reach to the next level, which is like a two variable equation, I'm not able to solve it. So it does not mean that the level will stop again. Like, I won't be able to go ahead. So what happens is the system will hint me as to what steps to follow, how to go ahead, and that's how I learn better. Then we come to Dreambox Learning, an adaptive math program for K8 students. It dynamically adjusts the learning path and teaching methods in real time and provide personalized instruction. Then comes Duolingo. All of us might have interacted with this platform, and it actually helps you understand and learn languages in, in a very broad way. You have listening skills, speaking skills, reading and writing. All of they are integrated um, in a very cognitive friendly manner, I would say. Then there is Jill Watson, which is a Georgia Tech Lab. It's a AI teaching assistant used in a computer science course, basically. It responds to students' questions in an online forum, freeing up a human TA to focus on more complex students' needs. The future of neuro-edtech. So the future of neuro-edtech has a lot of questions to be answered, especially in a country like India, where the actual education system has some or the other flaws. Although it's very difficult to control a system which is this big, but we can make small efforts in order to just, help the children at least get engaged in the academics or in the education sector in order to make them lifelong learners and not prompt them to just stop in between because they're not interested in studying. So what can be done in the unanswered questions in the research prospects thing is we can see how effectively we can test neuroscience lab findings in the real world. So the research does not stay in the labs, it comes to the industry. We have to personalize learning, which is, can technology truly adapt to a student's unique cognitive state and support their individual learning differences? So the thing is, no two people are same, and so the learning method should not also be the same. So this is how hyper personalization models would work. Then the long-term impact. What is the lasting effect of a screen-based learning on core cognitive skills like attention and memory? So you're continuously looking at a screen again and again for the whole day for different kinds of purposes. You have to study, you have to play games, you have to reach, see movies, or you have to do some other activities. But what is the impact of such a long screen time on us? And what can we do to, curb it basically? We have to be with the screens because, we do not have a choice. But then our sensory motor skills will be also developed while we use the pen paper method of learning. Then we come to emotional resilience. How can technology be designed to help students regulate emotions and build resilience based on brain science? So neuroscience can help children understand their emotional states, their moods, and accordingly they can help themselves make a proper schedule as to how they should regulate their emotions, how they can actually build up a schedule, a study schedule, or they can build up their schedule for hobbies so that they're not overburdened. Then then comes the most important part, the teacher training. What is the best way to teach educators valid neuroscience principles and prevent the spread of neuromyths? So the teachers in these days do not have a very good training. So if they have a very good training part in terms of, you cannot teach a child if you are not being a child at that point of time. If I am going to teach, suppose class 8th, and if I go there and I just treat them as just teenagers moving around here and there, I won't be able to understand them, I won't be able to teach them. You have to come to their shoes, you have to come to their own mental state at that point of time in order to actually teach them in a better way. Then the actual major implication that this would have is the policy and the ethical implications. How can neuroscientific findings be translated into effective and equitable K-12 education policy without leading to oversimplification or a new form of neuromyth? So while we are doing all these things time to time, we are monitoring everything, but all this should be translated into proper education policies in order for the national implementation basically. So you have to start small and then go towards, exploring the whole ladder and then go towards the top and then make a policy. So the policy recommendation should be based on what kind of socioeconomic status a country has, what kind of learners the children have, the country has, and what kind of, the environment the schools are providing. So this is how the things should navigate upon, and what are the challenges and the road ahead. Obviously with a lot of burden of technology here. First of all, we need to see the cost and the scalability. India being one of the world's most populous countries, it's very difficult to scale these operations throughout the schools, and then we have to see the cost as well. Then there is data privacy. There might be some concerns raising because of the security of the data of the children, because obviously they are under 18, their parents might be concerned, their school also might be concerned. So it's the duty of the researcher and the industry gap that is there to address such a concern. Then there is a lack of human touch. We cannot replicate the empathy and the motivation a teacher has to provide. So definitely with the age of AI, the role of teacher has not decreased. It has in fact increased and diversified. What is the road ahead? So we can focus on hybrid models that integrate with ITS and the human teachers. So why cannot the teachers use the ITS as a TA and not as, roadblock to their career? Then we can actually help, excel in the education system implementation of such policies. Then we come to develop systems that can understand and respond to emotional cues, which is a part of effective computing. And then improve the accuracy of the student models to provide even more precise feedback. So basically, what we have to do is teach in a hybrid method, develop their emotional resilience, and help them build for their future. Then we all have to do is give effective and implementable feedbacks to the students who can actually, and now this whole model can actually help in the system integration of technology, education, policy, and psychology, and all together come to form a perfect education system for the future. So these are my views, and thank you for bringing a great audience. I would like to welcome more questions and discussions on these points. Thank you.
Sure. So, Prerna, thank you very much for bringing us to a very, I think, close to a very emerging area where we are all a part of it as a parent of 12, as a parent of a grade 12 child, and I'm sure my colleagues and also the audience, I think you'll see that we are all a part of this, experiencing the new form of learning, the access pathways changing, access to information coming, through more than one way. Earlier it was the teacher and the school, but now the information comes to us because I have something with me and it is a portal for information. So could you share from your experiences some unique scenarios which have come, which you came across? Something which was like maybe part of your research or part of your implementation here, which is so that it can give a little more deeper insight or more specific about what you do, something it got excited and something where you got surprised. We would like to hear them.
Okay, so let me just inform you, I am very new to the industry academia sector. I am just 1 year into my career. And in this short span of my career, what I have seen is children are very, very curious to learn. No matter how less of facilities you give them, they'll figure it out. So there was this one school visit that I went to. And what happened was I just took very random worksheets for them to just complete. I wanted to see what their aptitude, basic aptitude is. So one of the child, he was around 14, 15 age, and I just gave them a question, draw your favorite toy or something. That kid drew a game, like the screen of the game, which was so accurate that I would see that there are 3D models that he could build, and they were so precise that the cube should be this small, the character is this big, and this shape perception, the kind of characterization that he did at that point of time, and then he was explaining me that in this level this will happen, this level this will happen. So I was like, I was kind of shocked because at in their socioeconomic group, I would never expect that, you know, some a kid who barely has a phone for half an hour a day can draw or imagine a game which is this precise that I cannot even, you know, draw on a designing platform like Figma or something. So it was kind of very shocking, and um, that gave me an inspiration that, you know, um, we do not have to, you know, force the children to study. We only need to aid them to study. They'll do their work. So this is how I came with certain ideas onto how, you know, the teachers should be involved in this, because in those schools, teachers just come, they teach, they write 5 questions and answer, and they go. That kid could not write a 4-word sentence in English, but he could explain me the whole gaming system in 5 minutes. So that was kind of shocking to my part.
Thank you. Over to Neha.
Thank you, Ms. Prerna, and thank you, Dr. Akash, for that question. If anybody from the audience has any questions, they may write in the chat box or can even unmute themselves and ask. We have a lot of cognitive science students here, and I know that you also have a background in cognitive science. I myself am a cognitive science student.
Can you
And
type your question? I cannot hear you properly. The voice is coming like
can you hear
very
me? Can you
haywire.
hear me now?
Yeah. I
Hello.
can hear you now.
So I was just saying that many cognitive science students are here, and
Yeah.
I myself am a cognitive science student.
Okay.
So yeah, I was just asking from the audience if anybody has any questions, they can maybe unmute themselves and ask.
Neha, can you write the question? I couldn't get you in between. The voice was broken.
No, I was not asking anything. I think your talk was pretty much clear, and
Okay. All right.
yeah.
Thank you so much. Any inputs, any questions from the cognitive science students especially? Are they
So,
interested? What kind of like, you know, improvisations can be done? Any ideas? You know, we can have a small discussion.
we have some questions from our ready cohort. Chirayu.
Sure,
Over to
sure.
you.
Ma'am, can this cognitive therapy can we apply this therapy to the old one who is a stroke patient?
Actually, if we talk about this, the cognitive, I mean, are you talking about CBT or something, or are you talking about this, the presentation that I'm that I gave right now?
You gave about younger students, younger childs, right? I'm talking
Yeah,
about the people who is suffering from stroke and they lose their cognitive, I mean, their
yeah.
consciousness. Can this be applied?
Definitely. Yeah, definitely. Certain amount of cognitive training over the period of time, around 4 to 6 months of proper cognitive training, which involves a lot of cognitive parameters, especially attention, executive functions, memory. All these are actually available on different apps. They are on a paid subscription as of now, and they are actually helpful. Although they might seem repetitive, but in the longer run, they'll help. Surely help.
Thank you.
Any other questions from any students? No. I know there are a lot of cognitive science students. So Kanishka, Brishti, I think it's your domain, your game. So what are anything you wanted to clarity or you want to give an input? Anybody working on a similar area?
Either my PPT was
So
too clear or nobody understood anything.
am I audible?
Yeah.
Yeah, so actually, there was this one project that I was involved with, at least at the conceptual level, and I think my
Okay.
friend is taking it up at the execution level, where he's trying to build an adaptive, build a AI, based tutor for students, where
Okay.
what we are targeting at is like when you said that statement, no, that one approach doesn't fit all. That particular, and we had started this project based on that idea only, and we had this thing that how to cater to the different learning styles that people have, and we would basically be using AI to first of all identify that what unique learning style each kid has, and then how the modules, the same curriculum and the same content that these kids have to learn, how to adapt that to the needs of these different learning styles. So something like that we were developing. Maybe you could have some insights or ideas on that. So that would be helpful for us. We are still in the the conceptual phase and working on it.
All right. My first input would be that whatever model you are designing right now, whatever conceptual like thing you are designing right now, always include the developmental stages of the child in terms of what age group are you catering to? Are you catering to school groups or to the higher
Right.
education groups?
So right now we have thought to start with the school kids only, at least
Okay.
eighth and above, and then
Okay.
we'll see.
All right, so classify them into standards like class 8th is one, ninth and 10th should be clustered in one, and 11th, 12th should be clustered in one group. So with class 8, you can go very diverse because, right now they are in their learning stages, their elementary school stage. So you can do that. When you come to ninth, focus more towards what is applicable in the real world scenario. Okay. And whatever learning strategies, I wouldn't say learning strategies, the cognitive strategies that you'll be suggesting should not be theory based. They have already read the theories. Okay, they can read theories from YouTube and stuff like that. All you need to do is, create a model which helps them learn in terms of nudging. So one question, you have to solve one question. Suppose in mathematics, some chapter takes take polynomials. Okay, so solved, and then the nudge would come, would you go to would you like to go to the next level like this, or would you continue with a game, and then that game could be something which enhances their one of their cognitive abilities. So you have to merge the cognitive education gap, basically give them a cognitive task to do in a gamified way for a very short time, like 2 minutes or something. Then that would refresh their mind. Then come to the education part of it, give them a few questions to do, then ask them what was interesting. You have to continuously first take their feedback because this whole concept is kind of new. uh, and then when you have to train the AI, or when you have to, even for your own feedback, you have to explore certain things like this. So bridge that gap of cognition and education. I think you'll be able to go with that. And when you do for 11th and 12th, make it more concrete towards higher education. What kind of and skill building as well, what kind of skills would give them a job. So have cognitive tasks relate to those skills and then go ahead. So I think that mapping would be fine.
Yes, yes, that's useful. So, Prakash, do you have anything to say further? Or I think
Yeah, I think maybe one
so. I would
last.
like.
Yeah, I think
I
one last call for any questions, inputs, feedback, or maybe we request Prerna to share her contact information, email on the chat box. So if anybody has any questions, they can reach out to you. And I think IIT Delhi has a very unique cognitive science
Yes, yes.
program which attracts psychologists, engineers, and mathematicians and physicists. And I think we have had great experience working with them. They bring their perspective. So maybe they can reach out to you and likewise the vice versa.
Absolutely. I've sent my email ID and now I'm just giving the LinkedIn account so that you can reach me out.
Okay. Thank you, Ms. Reena. Akansha, can you present the Springer voucher to Ms. Reena? So, ma'am, we have this small token of appreciation for you. And
Okay.
Dr. Akash, I would like to request
Yeah,
you to maybe present that.
right. Yeah. So actually, I'm very pleased and delighted to extend this appreciation voucher for the speaker, Cobotalks speaker, 54th Cobotalks speaker, Prerna Dash. And, maybe you can reach out to the Springer online website where you can use this voucher to get some good books. So I was
All
talking to my
right.
professor. Yeah, this is for you and, further readings. And I'm sure, for the joy of learning and reading. Over to you. I was talking to my professor over the weekend during my MTech professor, and he was also sharing several new emerging situations where he finds himself sometimes limited by how much the students are learning from outside. And so I think he was sharing some thoughts. But another unique thought which came to me was from a friend of mine where he was encouraging everybody to at least try out. So maybe the new learning systems, we should not be restricted ourselves with whatever we were doing because we are evolving and the technology is also evolving. So he was encouraging all of us to use this system. So but at the same time with guardrails, I think sometimes they can immerse you very, very deeply. So you can have a self-defined as, or maybe the human connect always there without. So cobotics is part of that, human robot collaboration, the technology with human in the loop. So I think, yeah, with that, over to you and Neha, and thank you so much, Prerna, for joining us this evening.
Thank you
Thank
Thank
so
you.
you
much,
so much.
guys, for having me.
Thank
And
you so much, everyone, for joining. Yeah. Sorry, Ms. Sheila.
yeah, please. I would really like to visit IIT Delhi again. Big fan of the cognitive science program and the people who are there. The interaction between the departments is like tremendously well organized and the collaborations are really good. So definitely would like to be a part of any project if possible and would like to contribute my knowledge to it. Thank you so much.
Thank you. Thank you very
Thank
much.
you. Thank you so
I've
much,
shared my
everyone.
LinkedIn account as well. You guys can reach out to me, and we can have a chat. Thank you for joining. Have a great day.
Thank you, everyone. Thank you so much
Thank
for
you.
joining once again.
Thank you. Good evening. We'll sign out.